Okay, now with the renders done, let's jump into Nuke and load in the files we just rendered. Just hit R to load a file. Let's load in the HDB10 2K plate. And let's load in the renders as well, so we have all of that available. Go to HDB10 and renders will be under R&DR. And here you will have all of them, so let's just load them in. I will also load in the chrome sphere and the gray sphere. So I need to hit S and set my frame range in the project settings. I'll just go to frame 1125, since that's the frame we rendered. And I'm just going to save this under HDB10 in the Nuke folder. First thing is we want to create the OCIO color space node and switch the input to the default ASUS 2065 setting. And select both images and hit M to merge both images. Our plate doesn't have an alpha channel, so add a shuffle node and to make sure the alpha is solid. And now hit Shift X while you have M at the merge node selected to swap the inputs. Okay, now you can see the render. Now the plate we loaded is distorted. So the first thing which we want to do is set up the lens distortion. So hit R and under color, you can find the lens charts where you will be able to find the 24mm T16 distortion map. All plates we're using were shot on a 24mm lens. This is currently in the wrong resolution, so add a reformat node and we will want to match the rendered resolution. So in the reformat, select 2102 by 1109 as resolution. And then we just need to create an STMap node and connect that to our render pass. And in the STMap, switch the UV channels to load the RGB or RGBA channel. So that's the distortion setup. You can see a little bit of stretching here because it distorts inwards into the plate. And to fix that, we just add a reformat node because our plate is actually 2048 by 1080 in terms of resolution. So in the reformat, select 2K DCP and we want to do a center crop to crop out the extra pixels. And also set the resize type to none for the center crop. If we take a quick look at the EXR file here, we have all the different AOVs available. Depth would be the Z-depth output, and below it are all the cryptomat AOVs, as well as our lights. And these we can use to relight our render. Before we look closer at the AOVs, I want to show you the Z-defocus node, which uses these depth paths to defocus the render. When presenting your lighting, you don't necessarily have to show it with defocus, but it can actually help sell your lighting because your CG will just feel a little bit more integrated into the plate. So it depends a little bit on the supervisor. When I present my lighting, sometimes I add defocus as well as black levels just to integrate everything a little bit better. And if comp has started on the shot already, they might have a setup available for me to grab and then I just show it through their comp. Now to defocus your image, you can use the Z-defocus node. The depth Z is the correct channel, so it's already set up. And the default focus plane is 0. So everything will be out of focus a little bit. Now the math we want to switch to depth, which directly uses the depth values. And to figure out the values, switch the output results to the focal plane setup. This will color code the image, and basic red areas are closer than the focal plane, green areas are in focus, and everything which is blue is further away than the focus plane. As you can see, everything is out of focus in the viewer right now. So in the viewer, you should see a little focal point, and just left click on it and just drag it to the area you want to be in focus. I kind of want to have my focal point around the eyes. You can see that the focal plane is infinitely small, and that's because the depth of field is set to 0 right now. So we can increase that a little bit and to kind of get half of his face in focus. Now switch back to result. It's very subtle, but if you toggle the node on and off, you should see the area closest to camera getting a little bit out of focus. So I want to exaggerate the depth of field a little bit. Switch the filter type to bladed. This will let you define more physical lens properties like iris blades. By default 5, you can increase that a little bit, and that gives you slightly better depth of field. To increase the depth of field, you can increase the blur size. Look at the window here where it's super close to the camera. It gets really defocused, but it feels like the shoulder is a little bit further away. It's possibly comparable to this area here. So possibly the size is just a bit too high. So we just reduce that. Yeah, that's better. So this is how you use the Z defocus node. And just to show you, let's look at the depth channel. If you sample the values with Control left click, you can see the values in the red channel. And if you gamma down the image a bit, you can see the character in the depth channel. The other thing I always do, and I always encourage my artists to do when presenting the lighting, is to have the chrome and gray spheres displayed as a diagnostic tool to see how the ref spheres and the CG spheres compare against each other. So load the reference. I usually merge them over the plate in the corner. We will have to scale them down a little bit. I use transform nodes to position and scale them. And I do the same for the reference images. You could set up a small Nuke template for this, so where you could pull these in as needed for any new shots. Okay, it looks like these guys need to be a little bit smaller. And add a shuffle node for the ref images and make the alpha solid. All right, now we have our chrome and gray sphere setup. Let's just take a quick look at the AOVs. What I want to show you is how to use the cryptomats. So if we take a quick look at the AOVs in here, we have all these different cryptomats available. To use them, create a cryptomat node and just connect it to your render. And if you view the node, you can see the different geometry passes you can select to create mats from. You can select what type of ID the cryptomat is based on. Because the way Katana resolves textures, this asset has a shader assigned to each piece of geometry, which means you won't see a difference between using geometry or surface shader IDs in Cryptomat. If one shader was assigned to several pieces of geometry, they would be grouped together into one selectable object. So to select something, you can click on the picker Add and then Control left click. That's how you add geometries to your selection. Hit A to view the alpha. If it doesn't display anything, your viewer needs to be in the RGBA mode for that to work. So if you switch to the alpha to see the mask it generated, it's very useful if you want to create specific areas. And this gives comp a quick way to create masks to adjust certain areas. For example, if you create a grade node and pipe in the cryptomat into the mask input, and now you can control these areas and grade them. And then the other thing I want to show you, and this is very helpful if you need to rebalance your lighting after rendering, is using the light AOVs. So if you want to use your light AOVs, you have to shuffle them out. So in this case, we have 3 AOVs, and I'll just quickly create a little setup for this. Select all of them and hit M, and then switch the operation to plus in the merge node. Now, if you compare before and after, you should not see a difference because basically adding the different lights together should result in exactly the same image. And now what you can do is rebalance each individual light. Let's say my environment light is too dark. You can use an exposure node, switch it to stops, and then just change the exposure. I use the exposure node because it makes it easier to push the exposure values back to Katana. You can just add the exposure value to the set exposure in Katana. With the gain node, the math is more complicated. If the gain in Katana wasn't 1, you would have to calculate the offset. Worse if you're also using exposure at the same time. So I would suggest to just use exposure. If you need to change the color of the light, that's when I would use a grade node to tint the light and transfer the results to the color input of your light shader. When I do these kind of tweaks, I set up my Nuke script to apply the same changes to my spheres, so I can see the changes in relation to the reference spheres. Be aware if you do this, you have to switch your over node to merge all. Otherwise, the AOVs don't get merged. And I then link the values with Control left click. And then just drag them down into the node you want to control. And now I can basically change the exposure of my character, and it changes my spheres at the same time. So when I present my lighting, my reference spheres match my character lighting. So this is a very common and valid workflow, and a great way to quickly do tweaks in comp if you have to. And then the last thing which would be left to do is adding a write node and writing out your image and presenting them to the lighting or VFX supervisor.